Ladies and gentlemen, welcome to another video on my channel. In this video we are talking about explorative data analysis with pandas. We will do some crazy stuff like creating heat maps with correlation matrices and pairwise correlation charts, so be sure to stay tuned. If you have just joined this series, there's absolutely no problem at all, but I'm recommending to watch the previous videos. Before we are starting, let's take a look at the modules we need to import, that is pandas as PD, matplotlib, pyplot as PLT, and newly we need Seaborn as SNS. As in our last tutorial, we will work with the serial dataset, which is linked in the video description. After creating a data frame out of that, we got this frame here containing columns which include the ingredients like protein, fat, and sugars, and we got this numerical index here. So our first step for an efficient and meaningful explorative data analysis is to have an overview of key statistical measures. And that is easily done by just calling the describe function of this data frame. Pretty awesome feature of this describe function is that it excludes the non-numerical values. As you see here, we have 3 columns containing names and some letters here, and the describe function is just ignoring that and starts at calories, which you are seeing here, right? So what do we see here? Well, we have some statistical measures like the mean, standard deviation, the minimum, and the maximum. And these are quartiles here, by the way. Your task now as a data scientist or data analyst is to find anomalies in this table. And if we're actually doing that, we see that we have negative values, which can't be true as there are ingredients here. So if you have a food containing negative sugar values, I'm really interested. Drop me a comment. Until then, I'm assuming that these values are wrong. And we have to get rid of them, otherwise we could draw wrong conclusions out of the data. So let's get rid of them by accessing those columns containing those negative values here. And we can do that by creating a Boolean mask. And that is done by defining df and then accessing the first column containing those negative values, which is carbo. So we are saying equals to -1. And we have to put that into parentheses. If you have no idea what I'm doing here, just click my previous video. This is creating a Boolean mask. Then we are accessing the next column, sugars, equals to -1. And the last one is potassium, awkward name here, -1. And we are executing that, and we're getting this Boolean mask here. And as learned in the last tutorial, now I'm just using the data frame with the argument of this Boolean mask as a selection, and if I'm executing that, we are getting this data frame containing those values which fulfill these conditions. And we're seeing that we actually got them. So we have this carbo -1 here, this sugar -1, and the potassium -1 here. Dropping rows in pandas is pretty easy. You just need the index of the row. And we actually got them here, right? 4, 20, and 57. An alternative approach would be to just use the index here, and you will get those indexes if you are using that. So if I'm executing that, I'm just getting 4, 20, and 57 here, right? And let's store these indexes in a variable which we are calling delete. Right? So delete is just containing the index values 4, 20, and 57. And how can I drop them now? Well, I'm just typing in df.drop and take this as an argument as these are the indexes. So I'm dropping the rows with the index 4, 20, and 57 here. And if I'm doing that, pandas provides me this data frame without those -1 values. But you have to be careful. This is just an output here of this syntax. But actually you have to store this new data frame into our old data frame. Otherwise the data frame wouldn't change. So I'm showing you what I mean here. So you are seeing we have 74 rows now because we don't have the -1 values. And if you are just calling the df now, which I'm doing right here, you will get 77 rows here, right? So in the data frame, there is no change until now. So you have to assign this data frame to this new data frame, which is created with the drop function. So just type in df equals to df dot drop and then the delete variable as the argument. And if we are executing that and actually printing that out, now we got the new data frame without those negative values. Perfect, right? Now let us call the describe function again to check if we got everything right now. And as you see here, we have cleared that, right? So we have the lowest value for carbs is 5 now, lowest sugar value is 0, and lowest protease value is 15. Perfect, right? So no more anomalies until now here. Now finally, we are ready to start with some analysis. Let us first take a look at those cereals containing 0 sugar. That is easily achieved by just using Boolean indexing. So let's type in df of df sugars, which equals 0. And what we are getting here is a data frame containing those 0 sugar cereals. What is interesting now is that those cereals have a rather higher rating, right? So if we are checking the mean rating of all cereals here, 42, we are noticing that these values here are distantly above the mean. With that in mind, we will check for that later again. But first, we want to get all relationships between all ingredient variables. That is easily done by calling the core function of the data frame. That is done by df.core. And what we're getting here is the correlation matrix of all variables here. So as an example, you see that there is a correlation of fat and protein of roughly 20%. And let's take another example. There's a correlation between calories and fat of 50%, which makes totally sense, right? Nevertheless, this table is kind of messy. It's hard to keep an overview here. And there's a great tool provided by Seaborn, and that is a Heatmap. And we will actually call that Heatmap by just typing in sns.heatmap, and we are taking this correlation matrix here as the argument of this heatmap. If we are executing that and of course call the plot by plt.show, we are getting this very nice heat map here. Now let us understand this heat map. Well, the lighter the value here, the higher the positive correlation, and the darker the value, the higher the negative correlation. Let's take two examples here. Well, it seems to be that the rating is positively correlated with a high protein value. And also, the rating seems to be negatively correlated with a high sugar value. And that is what we have actually observed, as you remember. Now we want to find out more about this relation between rating and sugar. And therefore we can use the concept of pairwise correlation. And Seaborn actually provides a pretty nice chart for that, and that is called by sns.relplot. And then you are defining the x-axis as our rating and the y-axis as our sugars. And you have to specify the data as our data frame. And of course, we have to call that by plt.show. And if we are plotting that, we are getting this pretty nice chart here, right? And we are actually noticing here, the lower the rating, the higher the sugar, right? And that is pretty awesome, right? We see that there is this relation between rating and sugar, which is clearly shown here. And we found our first pattern in the data, and that is actually pretty nice, right? Of course, you can change those variables here and find other relationships between the ingredients. It's actually pretty interesting, and I recommend you to play a bit around with that. Last but not least, I would like to cover Boxplots here, as I'm considering them to be important for explorative data analysis. So what have I done here? Well, I'm storing every macro ingredient, so that is protein, fat, carbo, and sugars, in a data frame, and I'm assigning that to the variable macro. So this is just a data frame containing of the macro ingredients here. And I've created a boxplot by calling macros.boxplot and showing this graph here. A boxplot helps us to understand the distribution of the data. For example, the length of the box is the so-called IQR, that is for interquartile range. that is nothing more than the difference between the third quartile and the first quartile. In easier words, we are seeing here that the dispersion for sugar is higher than for every other microingredient. For protein, that is the lowest. That's it for today. I hope you enjoyed watching this video. In the future, we will cover some more complex data sets to do explorative data analysis, of course. I'm really looking forward to see you in the upcoming videos and see you next time. Bye bye.